parts of a circle. Naturally, every point on the circle is at equal distance from the center. Naturally, every point on the circle at equal distance from the center. Here, 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 here. Equal distance. Here is a circle with a center C in 4.24. Okay. A, P, B. A, A, P, B, M. A, P, B, M are points on the circle. You will see that CA, C, CA, CP equal CA equal to CP, CP equal to CM. Each of the segments CA, CA, CP, CP, CB, CB, CM is a radius of the circle. The radius is a line segment that connects the center to a point on the circle. The radius is a line segment that connects the center to a point on the circle. CBM, CB, CB bar and CM bar are radii. So this is a singular, plural is the radius. Such a sorry, such that CPM are in a line. CPM, 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 CPM are in a line. PM is known as diameter. PM is known as diameter of the circle. Is a diameter double the size of a radius? Yes. Is a diameter double the size of the radius? Yes. PB, PB is chord connecting 2 points on a circle. Chord or chord. Is PM also a chord? No. An arc is a portion of a circle. An arc is a portion of circle. If P and Q are 2 points, P and Q are 2 points in figure number 4.25. You get the PQ. PQ we write it as arc. This is arc. An arc is a portion of a circle. So if P and Q are 2 points, you get the arc PQ. We write it as PQ in 4.25. As in the case of any simple closed curve, you can think of the interior and the exterior of the circle. In the case of a simple closed curve, you can think interior and the exterior of the circle. A region in the interior of a circle enclosed by an arc on one side, and a pair of radii on the other two sides is called a sector in 4.26. This is this point sector. This is a center. This is the segment inside of the circle. Sorry, inside of the circle. A region on the interior of the circle enclosed by a chord and an arc is called segment of the circle. Take any circular object, use thread and wrap it around the object once. The length of the thread is the distance covered to travel and around the object once. What does this length denote? The distance around a circle is its circumference. Take the circular sheet, fold it into two halves. This one. Crease the fold and open up. Do you find that the circular region is halved by the diameter? A diameter of a circle divides it into two equal parts. Each part is a semicircle. A semicircle is half of a circle with the end points diameter as part of the boundary. Graphics, motion graphics using points, lines, and surfaces. Using motion graphics using lines, points. See here, geometric animation. In this geometric animation, see here, is the geometric animation. See here, circle like this, curve, and making circle, small curve, and enlarging. Geometric animation, another one example of geometric animation. Here, every plane contains at least three non-collinear points. Three non-collinear points. Three. One, two, here. Here, B, C, D. Here, F, J, C. For any two distinct points A and C, there is a point D between them. For any two distinct points A, and C, there is a point D between them. Among any three collinear points A, B, C, one always lies between others. Any three collinear points A, B, C, one always lies between the other. From here, from here, from here. This one, from here, here, here. This one lies from other. If B is on AC and C is on BD, then both B and C lie on AD. If B is on AC, B is on AC, C is on BD, C is on BD. Then both B and C, both B and C lie on AD. If B lies on AC, B lies on AC, C lies on AD, C lies on AD, B lies on AD, B lies on AD, C lies on BD, C lies on BD. The converse is also okay. If A, B, D, A, B, C do not collide. Yes. F lies between A and B. F lies between A and B. F lies between A and B. C lies between B and D. B and D. There is point E. E, which is E. Which is C, E, A. E, and D, F. And D, F. Which is E, F, E, E, A. And figure, this figure, next figure, if C and D, C, D lie between A and B. C, D lie between A and B. That is CD line. Inside AB. Inside of this AB, CD line. In this figure, if C lies between A and B, then AC has no common point. This is CB. AC no common point. This is CB. Any points of AB lies either AC or CB. Here in this next figure, here C, if C lies between A and B, C lies between A and B. Any point of M of AB not, that is M not equal to C, M is not equal to C, lies either on AC or on CB. If O divides A and C, if O divides A and C, does not divide C and D. Every point, except the first and the last, lies between 2 points, lies between this point from here, this point here, this point, both. So lies between the 2 points with the adjacent in n numbers. Any open interval contains infinitely many points. Any open interval contains infinitely many points. So this is clear.